All right, guys, we're back. Um, Today I plan on. That was weird. Okay. Anyways, oh, what just happened? Um, I don't know what I just did. Okay. Um, so today we're gonna be doing chemistry. Um, these two decks are pretty much what we're gonna be doing. Um, right now, it coincidentally lines up to be exactly 70. Uh, I don't know if it's gonna stay that way. In this deck, I already suspended like 3 cards. And the fifth deck, I don't think I suspended any, but it's possible. Um, but yeah, obviously you guys know that we suspend as we go along, so we'll see. We'll see how many cards we actually end up doing. The ones in the fourth chapter seem to be pretty easy. It didn't seem to be anything too crazy, so I'm looking forward to that. As you guys can see, I unfortunately did miss a day of reviews. So I'm gonna have to make up for that tonight after today's stream. Um, and yeah, we could just get started. Law of constant composition. Um, I don't know. Element composition of a pure substance never changes. Elemental composition of a pure substance. What does that even mean? Like water will always be water if it's there's only water in there. Like what does that mean? I'm kind of confused. What? What is the law of constant composition? I will. What is the law of constant composition? Okay, we are going to click browse on this one. Um, okay. What is empirical formula? It's the most simple whole number ratio for a compound. What is a molecular formula? It is the exact ratio of whole numbers. So rather than this like symbol, it's like it utilizes the same proportions as the empirical formula, but it's not going to be it's a multiple of that. Exact number of atoms of each element in the compound. Yeah. How do you find the percent composition of a specific element in a compound? Um, Basically, figure out the mass of. I think it would be like you figure out the mass of each one, right? And then the total mass of each one, and then add those up, and then you can figure out the percent composition by putting the mass of one element over the total and the mass of the element over the total, and you get each one's yeah. I think if I was right, I don't think I'm ever gonna get it wrong. So you know what that means? Sustained. What is the law of constant composition? It means that regardless of source, it's always gonna be in a constant proportion. What are the six major kinds of reactions? If we're going by general chemistry, we're gonna have a synthesis reaction, decomposition reaction. Uh, I think when I was removing cards, I also gained some familiarity. So synthesis, decomposition, neutralization. Uh, there's single and double replacement, but there's one oh combustion. There you go. Oh, it's called a combination, not synthesis. Oops. What are two criteria that a balanced equation reaction must fill? Uh, Two criteria. It has to conserve charge and it has to conserve uh, elements. Mass is what I meant to say. Um, is one thing getting broken down into two products? One reactant to two products. Oh. Combustion reaction is a reaction between two things that results in water and carbon dioxide. Oh, hydrocarbon is oxidized. Oh. What is acid plus base is equal to water and something else? A salt. I knew that. I thought of salt and I didn't say it. Six major kinds of reactions seen on test day are um, six major kinds of reactions: decomposition, um, decomposition, combination, neutralization, um, single replacement, double replacement, and combustion. Combustion. What are two criteria that a balanced equation reaction must fill? Mass must be conserved, so the same number and types of elements, and charge also must be conserved. One reactant getting turned into two or more products. How much volume does one mole of an ideal gas take up? 22.4 liters. What is the archetypal form of the combustion reaction? So a hydrocarbon is oxidized in order to form carbon dioxide and water. Acid and base is going to be equal to water and salt. Percent yield, it is the actual yield over theoretical yield multiplied by 100%. Actual yield over theoretical yield. Yeah. What is an oxidation state? Uh, I don't know. It usually is equal to the formal charge. Hypothetical charge an atom has if all bonds were 100% ionic. Um, so I'm trying to figure out where they got -6 from. So if we have Na is going to be +1, then the O4 is going to be -2. So, oh, I guess I see that then. Yeah, I see it. Okay. what is an empirical formula? It is the most basic whole number ratio um, for most basic whole number ratio in for an atom in a compound. This is the exact whole number ratio for atoms in a compound. Um, uh, uh, I don't know if you guys know. Hold up. Let me see if I can find the dude I'm thinking of. Hold up. I'm gonna mute my audio capture just so that I can see something. I want to see. I want to make sure I'm not lying about this. Give me 1 second. So, if you guys have ever watched Hunter x Hunter, oh, my camera stopped working randomly. That's weird. Um, let me fix that. All right. Okay. Okay, you guys can hear me. All right. No way, the camera froze again. What? What is going on? Hopefully it doesn't freeze again. That's weird. All right. So what I was saying was, I don't know if you guys have seen Zushi from Hunter x Hunter, but he's just a kid, and he says one of the things he says when like he'd be like, oh, he's a pretty small guy. So I'm gonna I'm gonna use. I know he technically says OSU, but we're gonna pretend like he doesn't, and I'm gonna remember it that way. To be honest, smaller charge. He's a kid, so he's kind of small. That's how I remember him. That's how I remember the endings because it'll make it more interesting. Um, what is an oxidation state? It is the hypothetical charge, assuming that all the bonds were ionic. It is the simplest whole number ratio. Um, simplest whole number ratio of atoms in a compound. Uh, combination, combustion, decomposition, neutralization, single replacement or single displacement, and double displacement. 22.4. Same mass and same charge. Uh, Hydrocarbon and oxygen to carbon dioxide and water. Actual yield over theoretical yield times 100%. Normality, I don't know. Measure of concentrations. Measure of concentration in equivalent of solute per liter. Equivalence of solid per liter. How many moles of our item of interest are in the solution? Transition metal charges can be identified. So if it ends in us, it's gonna be us, like the smaller one. If it ends in like IC, is gonna be the bigger one. It doesn't matter what the source is; it's always gonna be the same proportions. As intensity of a stimulus goes up, I don't know where this card came from. I'm gonna be honest with you, because it certainly there's no way it's supposed to be here. The frequency goes up. What is normality? It is the measure of concentration and equivalence of solute per liter. Decomposition is one product being broken down into or one reactant being broken down into two or more products. Acid and base, so water and salt. Six major reactions. So combination, combustion, decomposition, neutralization, uh, single displacement, and double displacement. What is an oxidation state? An oxidation state is hypothetical charge if all the bonds in the compound were ionic. What is molecular formula? Molecular formula is um, it is the exact whole number ratio of atoms in a compound. Can be identified with Roman numerals, but they can also be identified with suffixes. Um, is OUS for the smaller charge and IC for the bigger charge. What is percent yield? Percent yield is the actual yield divided by theoretical yield times 100%. What is so? This is a hydrocarbon being oxidized, turning into water and carbon dioxide. The simplest one over ratio in a reaction of of not in a reaction of like atoms in a compound. 22.4. Equivalence of solute per liter. What are the two criteria that a balanced conserve mass and conserve charge? Hypothetical charge if all of the bonds are ionic. Um, Combination, combustion, decomposition, neutralization, single displacement, and double displacement. OUS for the smaller charge and IC for the larger charge. Nice. 20 minutes. That's pretty solid. All right. Next. What is delta G? Um, Free energy change associated with something. Okay. Amount of available energy associated with a reaction. You call it endergonic. Endergonic reactions are non-spontaneous. Um, Exergonic. They are spontaneous. Can a catalyst ever make a non-spontaneous reaction spontaneous? No. What are four things that can affect the rate of a reaction? Um, Decreasing the, you can decrease, you can increase pressure, you can decrease the, uh, what's it called? The activation energy, you can increase temperature, and I don't know anything else. Concentration, that's, it's, that's like pressure. Like, I'm not gonna give it to myself, but that is pressure. Like, fundamentally, that is what I was saying. The medium in which the reaction takes place. Okay, I guess that's also true. Interactions between the molecules. Um, this is the free energy available to participate in a reaction. Associated amount of available energy. I'm about to suspend the first card, bro. I'm suspending this. I just don't see it as useful. It's not more useful than this card. Amount of available energy associated with a reaction. What are units of rate? This is concentration per like units of concentration per second, like molarity per, I mean concentration per unit time. Um, what is the collision theory for reactions to occur? Molecules must collide in appropriate configurations. What is the frequency factor? This is how often they collide. Oh, molecules colliding per second. What are the four things that can affect the rate of a reaction? The concentration, the temperature, the solvent, the catalyst. Yeah. How can you increase the frequency factor? Increase the temperature or increase the concentration? What is Gibbs free energy? Gibbs free energy is the amount of available energy for a reaction. What is activation energy? Activation energy is um, this is um, the energy necessary in order to get past the transition state required to start the reaction. What is the collision theory? It says that in order for like molecules to react with one another, they need to collide with one another in appropriate configurations. Frequency factor, the molecules colliding per second. The temperature, the concentration, the solvent, and the catalyst with less energy, then they don't react. Rate of a reaction is proportional to uh, the activation energy. What are the tenets of transition state theory? When molecules collide with sufficient, they form a transition state. What is activation energy? The amount of energy necessary to start the reaction. Compared to the reactants and products, the transition state will always have more energy. What is reaction coordinate? The x-axis of coordinate diagrams. Hold up. Wait, hold up. Bro, how far into the reaction you are? Hold up 1 second, guys. Um, um, what are the tenets of transition state theory? When molecules collide with sufficient. Okay. What part of the reaction diagram corresponds to activation energy of the reaction? Um, uh, what part of the reaction diagram corresponds to activation energy? It's the peak. The peak in the middle is like is right there. The difference between oh, okay. I mean, like, yeah, I did say it was the peak, but I didn't like elaborate. Uh, what feature of the reaction corresponds to the delta G of the reaction? It's from reactant. The difference between reactant and product, or reactant and product, something like that. Yeah, that's what I said. What are the tenets of transition state theory? Um, when they collide with one another with sufficient energy, they enter the transition state. Reaction coordinate, it indicates how far along in the reaction you are. What part corresponds to activation energy? The difference between the energy of the reactants versus the activation energy. So this, or bruh, the transition state. What is a reaction mechanism? The proposed series of steps the reaction takes to complete. What is an intermediate? Um, it's like it's not quite a product, but it's a substance that forms between your reactant and your product. What are units of rate? It's concentration per unit of time. What is a rate determining step? It's a step that is so slow that the rate at which the other steps proceed are rendered irrelevant. The slowest step. Yes. Um, I'm gonna I'm gonna suspend this card because I feel like I understand the concept. I don't need to remember slowest step of the mechanism. What is the Gibbs free energy? Gibbs free energy is gonna be the available free energy associated with the reaction. Um, the difference between the transit and energy between the transition state and the reactants. Um, a series a series of steps that must occur in order to get from the reactant to the products. Catalyst, temperature, ac- uh, catalyst, temperature, concentration, and uh, catalyst, temperature, concentration, and catalyst, temperature, concentration, catalyst, temperature, concentration. What is it, bro? Oh, the solvent. Damn. Molecules colliding per second. It is one of the products that are produced in the in between your reactant and your product. So it's produced by one of the steps and consumed by the next or by another. What is a collision theory? They have to collide. It means that molecules, in order to react, they must collide with one another in the appropriate configurations. Uh, what do you call a reaction with positive exergonic? That was wrong. I should have gotten it right, but that was indeed wrong. What is activation energy? The difference between the reactants and the transition state. Oh, oh, I'm selling all my leads. This one is exergonic. No. Uh, non-spontaneous. Spontaneous. What is a catalyst? A catalyst is an enzyme that reduces the activation energy of a reaction. Yes, without being used up. That is true. What are the four things that can affect the rate of a reaction? Um, the temperature, solvent, concentration, and catalysts. Endergonic. How do catalysts affect? They reduce the activation energy, bro. Like, okay. What is activation energy? Um, it is energy required to begin a reaction. It's how far along in a reaction you are. Um, the difference between the energy of the reactants versus the products. What is a catalyst? Um, uh, it is an enzyme used in a reaction but not consumed in order to reduce the activation energy. Increase the temperature or increase the concentration. Um, if you collide molecules with its appropriate activation energy, then it enters the transition state. They stabilize the transition state, bro. Where, like, this has a little more information, but I'm still suspending it, bro. How do catalysts affect reactions? Because how many times do I need that question? How do catalysts affect reactions? Um, they stabilize the transition state and lower the activation energy. How do catalysts modify reaction diagrams? Can you guys guess? They lower the activation energy. It fits in the square hole. Suspended. Um, do catalysts just speed up the forward reaction? Uh, that's a good question. Well, I think catalysts. I think there can be separate catalysts for the forward and backward reactions or reverse reactions. I think each direction has its own catalyst. Oh, I was wrong. What is a proposed series of steps to get from reactant to product? The activation energy, homogeneous catalyst. I don't know. Catalyst that is in the same phase. I'm assuming catalyst in a different phase. Okay. What is a rate law? Okay. These are probably gonna be a little more. These following cards that are coming are probably gonna be a little more difficult. Um, I'm changing the wording of this card. Um, compared to the reactants and products, the transition state will always have more. Formula to calculate the rate of a reaction. Um, do catalysts just speed up the forward reaction? No, it makes it easier in both directions. It is a catalyst that's the same phase as the reactants. Do products ever appear in the rate law? Um, no. What is a it is in the same phase, is in a different phase than both the reactants or the reactants. Is the rate constant a constant? By reaction, yeah. Oh, okay. Rate law is also known as the rate equation. What is the Arrhenius equation? I don't remember. It starts with a K though. K is equal to AE AE to the power of negative activation energy. Uh, damn. AE to negative activation energy divided by RT. Damn. It's going to be the rate is equal to K times the concentration of A to the power of something times the concentration of B to the power of something. And the exponents are experimentally determined. What are the units of rate? Like concentration over time? No, it depends on the conditions of the reaction. What is the order in terms of kinetics? The number of reactant is raised to. The order of reactant must be experimentally determined. Balance equation does not predict the order. Four things that can affect the rate of a reaction. Um, the temperature, the catalyst, the solvent, and the concentration. The energy needed to start a reaction. Um, Gibbs free energy is the for available energy for uh, like associated with the reaction. Arrhenius equation is K equals A E negative EA over RT. What part of the reaction diagram corresponds to the activation energy? It's the difference between the energy of the reactants and the transition state. It's the number that the concentration of a reactant is raised to in the rate equation. What is the overall order of a reaction? It's the orders summed up. How do we experimentally determine the rate constant and the orders of a reaction? Um, the rate constant and the orders of a reaction. Uh, mm, that's like I feel like this doesn't give enough information. Like I don't think that I would know how to figure it out based off of this. I'm gonna suspend this card because it's not useful enough. Actually, let's see if Gemini will give us a better response. It did not, in fact, give us a better response. Let's see on Google Because if we could just find the actual way to do it, then I think it would be. I'm gonna write down basically the rules in the card. Hold up. That's pretty much the basis of it. If you double this gets doubled, so it ends up having an exponent of one. If you double this, it also ends up doubling. So, or like compared to this baseline, it also ends up doubling. So it gets a two. When you do this and you multiply this one by two, it does nothing. So it's gonna get a zero. The amount of hydrogen literally doesn't matter. It does not affect the rate. Okay. So, what is a reaction mechanism? A series of proposed steps that uh, to help you get from the reactant to product. Molecules colliding per second. It is a product formed in one step and consumed in another in order to create the product in the process of creating a product. What is the reaction coordinate? It's how far along in the reaction you are. Two molecules must collide with one another in appropriate configurations in order to react. Rayleigh is also known as the rate equation. You call that endergonic. No. What is a catalyst? Yeah. What is a catalyst? It is a enzyme that decreases the activation energy by stabilizing the transition state. Oh, well, all right then. How do catalysts affect reactions. Uh, Formula to calculate the rate of a reaction. K is equal to AE to the power of negative activation energy divided by RT. Brother. Oh my god. I was thinking the rate constant. What feature of a reaction diagram corresponds to the delta G of a reaction? Um, it corresponds to the delta G of a reaction. Um, the difference between the energy of the transition state and the reactants. Um, when forming a product, two molecules must collide with the appropriate transition. Like they must collide with the when molecules collide with the appropriate activation energy, they enter the transition state. This one is K is equal to AE to the power of negative RT negative EA divided by RT. It's in the same phase as the reactants. No. Um, Basically, you look at how much the rate increases, and then you look at how much uh, by what multiple the rate increases, and by what multiple uh, the reactants increased, and you see the relationship between them. So it would be if you doubled the reactant, it would be two. If as a result of that the product was also doubled, then it would also be two. So now you're trying to figure out what the exponent would be. If you're trying to go from two to two, the exponent has to be one. So therefore it's first order. This n is the most important, it most like pretty much the order of the number after looking at both of those things. What is the heterogeneous? It's in a different phase from the catalyst is in a different phase from the um, the reactants. No, it depends on the conditions of the reaction. What is a catalyst? It is an enzyme that lowers the activation energy without being consumed. Um, Formula to calculate the rate of a reaction. K rate is equal to K times concentration of A to some exponent times concentration of B to some exponent. What is activation energy? Activation energy is the amount of energy necessary to begin a reaction. Um, this is catalyst, temperature, concentration, and solvent. The exponent that the concentration of some reactant is raised to in the rate law. It is all of the orders summed up. Why do we need to know how to convert first and second order graphs into line graphs? Describe the graph of a zeroth order reaction. The order of this reaction is zero. Okay, we should just look at this now. Um, it's basically zeroth order is just proportional to time, so it's just like straight down pretty much. Because I guess that makes sense. Concentration is decreasing as time goes on. They're just in a second order reaction, it's increasing, but it's like it's not the concentration. It's not that the concentration is decreasing. It's just that the one over A is increasing. One over A is of course, well, one over the concentration of A, as A decreases, this goes up. So that kind of does make sense. I don't know how natural log works. I'm not gonna lie. As A increases, I don't know. I don't really know. The order is zeroth order. Okay. I'm actually gonna give myself hard on that. Why do we need to know how to convert first order and second order graphs? Because um, the slope of that line is gonna be equal to the rate constant. Describe the graph. It's a straight line down that's proportional to time. For a zeroth order reaction, uh, the rate law is gonna be rate is equal to K, pretty much. Integrated rate law. Okay. I don't remember what the integrated rate law was. Okay, so this can be correlated with remember this V equals V naught plus AT. It's like the same thing. For a zeroth order reaction, it just it's pretty much simple velocity, like the simple velocity equation. Um, so the first order equation is obviously a little more difficult. That's a little more difficult to get to. Um, Describe the graph of a zeroth order reaction. The rate is constant and it's like decreasing over time. Rate is independent of reactant. Uh, there's meters over, not meters. I always do this. Molarity per second. Describe the graph of a first order reaction. It's like it's decreasing, but like a lot less steeply than like the zeroth order one. Dependent on the concentration of one reactant. The less reactant there is, the more slowly it gets used up. So the rate law is going to be like rate is equal to K. The integrated rate law is going to be uh, concentration of A is equal to concentration of A naught minus KT. So yeah, definitely do not don't go 100% by the velocity equation just because it's like you have it's obviously going to be a lot harder. Like I don't want you like misremembering the sign. So just keep that in mind that the sign is different because in the velocity equation it's obviously plus. Um, Describe the graph of a zeroth order reaction. Um, So the rate is independent. The reaction rate is independent of the concentration of the reactants. It's decreasing, pretty much proportional to time. Describe the graph of a first order reaction. Um, the reaction rate is dependent on the concentration of one reactant. You can't determine the slope or the k value. The rate, you can't determine the rate constant off of this slope, so you need to turn it into a line. Rate law is also known as the rate equation. What is a reaction mechanism? A series of proposed steps to get from the reactant to the product. Um, Rate is equal to K. Uh, so A is equal to A naught minus KT. It is first order. How do we convert a first order reaction into a straight line? Um, you graph it according to the natural log. The order of this reaction is 0. Do products ever appear in the rate law? No. Describe the graph. That's kind of like this. As the reactants get used up, the um, the reaction goes slower. So the less reactants there are, the slower the reaction. Um, it depends. The reaction rate depends on the reaction rate depends on the concentration of one reactant. You can't determine the rate constant based off of this graph, since you can't figure out the slope, so you need to turn it into a line graph. Because you can't find the slope of those graphs, and you would need to use that in order to figure out what the rate constant is. What is a catalyst? A catalyst is an enzyme used to stabilize the transition state and reduce the activation energy. Um, K is equal to AE to the power of negative EA RT divided by RT. Um, Graph the natural log versus time, and then the slope is equal to negative K. Um, Basically, this is the multiple that you increase the thing by, the concentration of one reactant by. This is the amount that the rate increased by, the multiple by which it increased. And then you're going to have that raised to n. And then with these two numbers, you can figure out what n is. First order reaction, the rate law is going to be K is equal to A, concentration of A. Oh no, wait. Uh, the rate is equal to K times the concentration of A. And integrated rate law, this one is a little rougher. I don't know. Okay. it's so much easier to remember this one. And I feel like they love organizing it like this in order to make it seem like it's harder, but it's really not. This is at the end of the day, this equation is gonna. I want to redraw that parenthesis. That was too much. Like it's the same equation as the first one, but they want to make it look like it's so much more complicated by not organizing it in the same way. It's the same equation. It just has the natural logs in front of the concentrations now. And I'm like, up here they didn't really do that. But for some reason with this one they do want to do that. Formula to calculate the rate of a reaction. Um, the rate is equal to K times the concentration of A to some power times concentration of B to some power. Units, that's 1/seconds. Describe the graph of a second order reaction. Um, the graph of a second order reaction. Uh, describe the graph. Wait, oh, okay. Describe the graph of a zeroth order reaction. So the reaction rate is constant over time. Um, it's pretty much just like a straight line down. Um, it's gonna be rate is equal to K, and then A is equal to A naught minus KT. Oh, bumble. It was first order, bro. Um, uh, damn. Um, is gonna be this one is gonna be R is equal to K, and then A is equal to A naught minus KT. The graph, so it's gonna be the same as the first order, but it's gonna drop faster. So it's a lot faster of a reaction. It's gonna drop faster, and it's gonna like flatten sooner too. It's the reaction rate is dependent on the square of one reactant or the product of two reactants. Zeroth order are molar per second. Describe the graph of a zeroth order reaction. It's constant. It's independent of any concentration of any reactants, and it just constantly decreases over time. Describe the graph of a first order reaction. You can't find the slope, so you need to find it by taking the natural log or turning it to a line graph, whatever. Um, Describe the graph of as the concentration of that one reactant decreases, the reaction rate slows down. For first order reaction, um, the rate law is uh, rate is equal to Ka. Um, integrated rate law is going to be the natural log of A is equal to the natural log of A naught minus KT. How do we convert a first order reaction to a straight line? Graph the natural log of the concentration versus time. Um, and then uh, uh, so, and then the slope is going to be equal to negative K. Second, how do we convert a second order graph into a line graph? Graph the reciprocal versus time. The order of this reaction is first. For second order reaction, it's going to be either K or rate is equal to K A squared or rate is equal to K A times B. Product and the integrated rate law is going to be um, it's just going to be the same thing, bro. One over A is going to be equal to 1 over A naught minus KT. That was, or damn, it's plus KT for this one. Wow. The units are probably probably 1 over molar second. What is the difference between K and KQ? Um, how do we convert a second order reaction graph into a line graph? Graph the reciprocal versus time, and then the slope is going to be equal to the rate constant. How do you calculate KQ from K? Um, so K forward divided by K reverse. Okay. This is gonna be the zeroth order. Um, K A K A squared or K A B. It's gonna be 1 over A is equal to 1 over A naught plus KT. I think I prefer my answer. Let me look it up to make sure. I'm right. So we're just gonna leave it like that. So K is the equilibrium equilibrium constant for the equilibrium equation, and K is going to be the rate constant for the rate law equation. It's gonna be dependent on the square of one reactant or the product of two reactants. It's gonna be this like similar to the first order equation, first order rate law, but it's gonna drop steeper and it's gonna flatten faster or flatten sooner. How do you calculate KQ from K? So K forward divided by K reverse. Why do we need to know? Because the line graphs help us to determine what the rate constant is using the slope. Um, it's like whatever you multiply the reactant by, and the resulting multiple of the rate itself, and then you figure out the order by just solving for what's left. The units for the rate constant of first order reaction are 1 over S. Describe the graph of a zeroth order reaction. Um, um, Describe the graph of a zeroth order reaction. So it's independent of the rate is independent of any reactant, of the concentration of any reactant. So R is just going to be equal to K. Um, and it just simply decreases over time, bro. It's constant. Um, R is equal to K, and A is equal to A naught minus KT. So it's gonna be dependent on the concentration of one reactant, um, and as the concentration of that reactant decreases, the more slowly that it becomes consumed. Um, yeah, I think that's it. Uh, R is equal to Ka. Natural log of A is equal to natural log of A naught minus KT. First order reaction into a straight line. Graph the natural log of A versus time, and then the slope is going to be equal to negative K. This is going to be second order. 1 over ms. So graph the reciprocal versus time, and then the slope is going to be equal to the rate constant. What is the difference between K and KQ? K is going to be the rate constant for the rate law equation. The KQ is going to be the equilibrium constant for the equilibrium equation. Rate law is going to be KA squared or KAB. Integrated rate law is 1 over A is equal to 1 over A naught minus KT. Brother. Describe the graph of a second order reaction. Um, Grab the graph of a second order reaction. Um, Describe the graph of a second order reaction. Um, um, Describe the graph of a second order reaction. Mm, Describe the graph of a second order reaction. Um, so it's gonna be dependent on the square of one reactant or the product of two reactants. It's gonna plummet a lot faster than the first order reaction. It's gonna flatten a lot sooner too. It's gonna be a very fast reaction. For a second order reaction, the rate law is gonna be Ka squared or Kab. 1 over A is equal to 1 over A naught plus KT. Um, K forward divided by K reverse. Um, Rate law is going to be Ka squared or Kab. It's going to be 1 over A naught is equal to, no, 1 over A is equal to 1 over A naught plus KT. All right, we did it, guys. All right, we did. We did our 70 cards for the day. That was surprisingly fast. I think that's probably the fastest we normally get through 70 cards, to be honest. Besides like Psych Soch, we always know. But before we go on to do Jack Weston for the day, let's see, right? How many what percent of the deck we are through. I'm thinking it's probably close to like 25. I feel like we probably have hit 25 today. Let's go. Quarter of the way done. Okay. Right around this point last time was when I took my first practice exam. I don't know if we're quite ready to take our first practice exam, but I don't know. It might be time. It genuinely might be time to take it. Um, so I don't know. I'm not sure. I think we have done. So we've done this, right? This is covering some content. Uh, that is like boosting maybe our percentage a little more, but honestly, like it is still factoring into the percentage generally. So it probably might be important. On the like if we were to take a practice test right now, maybe there would be some usage that I'm not like thinking of immediately right now. Um, then so I feel like maybe a better indicator. Chemical, we've done 21%, which is good. We're at least close to 25. This one we've done 17. Okay. All right. See, that's why it's important to check individually. So we haven't gotten to 25. I would like to get to 25 generally. Pancow, I wasn't really taking into account. This one's at 34. So it's like boosting the other ones. Um, we need to get, if we did like maybe like more, if we probably just need to do, we definitely need to finish reproduction here. Reproduction and probably embryogenesis too. If we did both of those, then we would probably be like a lot more set. Here we're 16%. Okay. And here we're 19. Okay. So yeah, so we probably need like once I do chapter 3, then it's gonna be a lot better, probably. We'll probably do like a lot better on thing if every section is at least at 25. I don't know how if we're exactly close to accomplishing that, but All right. Let me pull up the let me pull up Jack Weston so we can do this. Jack Weston. It has an interesting name, I will say. Okay. Um, um, doo-doo-doo. Damn, I can't time this for nothing. Uh, okay. Hopefully, my headphone just gave me the signal that they're gonna die soon. I'm gonna hope that they don't die before this passage ends. All right. Well, not that audio. Um, that was not the audio I was trying to pause. All right. I really don't want to say these two, but I think I might have to, bro. I just don't see. I just don't. I think I'm using my internal biases to answer that question, but mm, damn. Oh, I misread the. Okay, this is a little different. I got this wrong because I read the question wrong. I didn't understand the question. Thank God. I wasn't sure at all. I genuinely didn't know. Yeah, it was realistically the reason why I didn't pick this one was because it said into one another. Like it was, they were like interchangeable or something, but it didn't. It didn't say that. Yeah. Okay. Did we get through? Was it three or four? Four. That is indeed what we like to see. Oh, bruh. Yeah. I always get so disappointed, bruh. I always get so disappointed because I'm like, okay, like I did all right, and then I look at the difficulties, and they be like, it's like terrible. Let's look at the. This has 90 comments. Let's look at the 90 comments. Clay ruined my day. Did I do this? Did I do this one? I don't think I did this one. I'm like looking at this all confused. Like why? Like what? Like what the hell? Where did that come from? And I did. I never even done it. I didn't do that one. We can look at the comments on this one though. 3 out of 6 bad day. Question one, really? That's funny. Um, let's see. Uh, the society, somewhere. Yeah, I feel like we just have to. I feel like when we do these, we genuinely, we just need to. We just need to read the comments on the day of. I don't think it's been a couple days, so I'm like looking at these like oh, like kind of like disattached from them. Oh, there is a comment. There is a comment. Someone commented. That is a fair. I feel like it sounds kind of like a cope if I'm being honest with you, but like he is making an argument at the end of the day. He is making an argument, and so I would definitely have just chosen that because I feel like how do you like my follow up question would be how do you prove something that's like only ethical? Like what can you show? What can I show you to prove that something is right or wrong? Like some people might say the Bible, I guess, or like whatever religious text that you use or abide by, like that I guess is true, is fair, but I don't know. It's hard to prove like via analogies or like stories or something like that. All right, but so we are done with another day. We today we hit 25% of the deck completed, which although we don't have 25% in every individual part, 25% in general is still great. Um, we are a quarter of the way there in 21 days. So it has officially now been 3 weeks, and we are 25% done, um, which is obviously very good. Uh, Basically, if we were to continue at this rate, we would be done by like we would be done within 80 days. So by day 80, uh, and obviously we've missed a couple days, we've made up a couple days, like so. I don't know. Hopefully we can just get this get this done. Um, we know what our objective is. We know we don't do U World every day or anything, but I don't know. I just kind of really want to do like a phase, like I just want to spend some time like only doing that. So like I like the like I just want to spend like 2 months like I just do questions. Um, and like most people would recommend against doing that, but I just really want to have like the baseline knowledge so that I can look at everything and be like, okay, like yeah, that's good. Instead of sitting here every day and doing the flashcards, and then I'm already like exhausted from learning the flashcards and doing the reviews, and then I just have like I don't know. I feel like it's too much. So I feel like it's probably best if we just leave it. There are obviously gonna maybe there are a lot of times that I come on the stream and I just wanna only do the U World questions. But I just know that that's not going to help me get the flashcards done faster. So I just try to figure out which is the best one for us to do. Today we did two chapters in chemistry, which obviously brings us a lot further in chemistry than we started off being. So yeah, maybe sometime on one of these future days we can do a whole thing of bio, like one big chapter. That would be my objective. I really really want to do. I really want to do one big thing of bio so that we can actually get that out of the way. Let me see. I'm literally on Anki right now. I'm trying to see why isn't it changing? I don't know why it's not changing it. I just don't understand. What is going on? Okay, there we go. All right. So, um, what? I think all of the decks are not using the same preset. So I think I've just been doing them. I've been doing them and it's not training FSRS in the way that it's supposed to. I know you guys can't see right now, but I need you guys to bear with me. Um, okay. Everything should be there now. Are these the actual numbers or is it just lying to me? 82, 100, 123. 5 is 123. Okay, so this one is not using the same preset. Okay, what if I close it, right? And then I change it to Anki Hub and save and open it. Yeah, no, I just need to change all the presets individually for some reason. It's not, they're not all using it. One second. I can let you guys see like what I'm doing. You guys can't exactly see. You guys can see the main screen, but that way you guys are at least on the same like app that I'm on. Um, okay. Like this one should be no, this one is on even this one is on default. All of these are just simply on default, bruh. That sucks so bad. If they're not using the same preset, they don't have the same settings. And I don't know if they're training the model that I want them to be training. Do both of these really have 70? I think they really have 70. I think I should change the. I think I should change the default to have like 5, just so we can. Like what? Why did they just change all of those to 5? But when I do this, it doesn't change all of them. See? I don't know why. I'm just fixing this now because I know that I don't want it to be training a model and just be wrong, bro. See, like, look, all these, I guess, are probably on default. Like, I wish I could just switch all of them. It doesn't let me though. Um, okay. You need to change every individual one too. It's not even like you can just change one of the headings or something. You need to change every single one, or else it doesn't work. Did I not just change this one? I did. Oh, it just doesn't matter because we're looking at the sub deck. We've done this like 50 times. Um, all right, that should be everything, if I'm not mistaken. Nope, still isn't. Okay. Bro, there's no way. All of these, they still have the same issue. Oh my God. This is costing so much time. Um, all right. Yeah, this is too many. We're not gonna, it was only supposed to be like a couple. Um, so okay, these numbers aren't too bad. What I was saying before was hopefully one day we can like I would really like to just go through a majority of these, like just because bio and biochemistry are like I hate them. I hate those days. And if you hate it, it's because you need to do more training in it. So I definitely need to go into them, like go into them a little more. And if we can get through even like maybe like these two and then half of this, then we'll probably be the 25% done with bio that I want. Um, but yeah, all right. Well, thank you everyone for watching. I hope you have a nice rest of your day, afternoon, evening, night,